In this video, we are going to be talking about significant figures. So we want to conquer significant figures. And it is usually something that we do in science. I've talked to math teachers and they don't really do this in math. So science is more concerned about having rules for the figures that we keep when we solve math problems. So let's get started with how do we know what figures are significant and which ones are not. A number is significant if it is a non-zero number. So what is a non-zero number? Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are all non-zero numbers. So that's pretty easy. If it's a non-zero number, we count it as being significant. So when you see a number, you have to learn how to count the significant figures. So for example, 47.3 grams, we're going to put a unit there because this is science. How many significant figures does that have? So we count the 4, we count the 7, we count the 3. So this has 3 significant figures. So that's pretty easy. What about this number? We have 0.5234, we'll say meters. So we ask, how many significant figures does this number have? Well, 0, we don't count this 0 in this number. We're going to learn more about the zeros in the next slides. But we count 5, 2, 3, and 4. So that's 1, 2, 3, and 4. So this number has 4 significant figures. Okay, a number is also significant if it is a 0 between non-zero numbers. Now remember, our non-zero numbers were 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are non-zero numbers. So a number is significant if it's between those. So let's look at some examples. We have 8.03. So when we're counting these significant figures, that's 1, 2, and 3. So this one has 3 significant figures. All right, that's easy enough. What about this one? 0.1502. Oh, we need to put a unit on there because this is science. So when you're counting these zeros, 1 we count and 1 we do not. So look at this rule. A number is significant if it is a 0 between 2 non-zero numbers. So this first 0 is not between any numbers, so we don't count it. So you're counting 1, 2, 3, and 4. So this one has 4 significant figures. We do not count this 0 right here. We count this one. Why? Because of this rule. A 0 between non-zero numbers. Okay, we have another rule about the zeros. A number is significant if it is a 0 at the end of a number with a decimal point. So really, with counting significant figures, you know all non-zero numbers are significant. So it's the zeros that we make up rules to know when to count them. And that's where students get the most confused. So let's look at this again. A 0 at the end of a number with a decimal point. All right, so let's look at some examples. So we have 7.00. So a 0 at the end of a number with a decimal point. All right, so this has a decimal point, and these are zeros at the end of that number. So when we're counting, this has 1, 2, and 3. This has 3 significant figures. Let's look at another example. 9.730 millimeters. I keep forgetting to add a unit. Let's put milliliters over there. All right, 9.730. So we count the 9, the 7, the 3, and the 0. Why do we count the 0? Because it is at the end of a number with a decimal point. So this has 4 significant figures. So let's look at this number, 0.0003502. All right, so lots of zeros. Some we count and some we do not. We do not count these zeros here. These are what we call leading zeros. We do not count them. We count the 3 and the 5. We count this 0 because it's between 5 and 2. We count the 2 and we count this 0 because it's at the end of a number with a decimal point. So 1, 2, 3, 4, and 5. This one has 5 significant figures. A number is significant if it is the coefficient of a number written in scientific notation. So let's look at some examples. Let's look at 4.0 times 10 to the 6 meters. So the coefficient is 4.0, and so we count the 4 and we count the 0. The 0 is after a number with a decimal. So this has 2 significant figures. You don't worry anything about this at all. Okay, another example. 8.50 times 10 to the negative 3 grams. This number has 3 significant figures. We count the 8, the 5, and the 0. We count this 0 because it's an ending number after a decimal. So this has 3 significant figures. Okay, so let's review the rules of significant figures. A number is a significant figure if it is 1, a non-zero number, which could be 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, a 0 between non-zero numbers. 3, a 0 at the end of a number with a decimal point. 4, the coefficient of a number written in a scientific notation. So let's talk about when a number is not significant. It is not significant if it is a 0 before or after the decimal point and before non-zero numbers. So here are some examples of that. We have 0.3, that is a 0 before a decimal point and before a non-zero number. It is not significant, so we don't count this one. Then we have our second number, 0.002. These 3 zeros are not significant. We have 0.037. These 2 zeros are not significant, so we don't count them. A 0 at the end of a large number written without a decimal point. These are what we call trailing zeros. So we have 1, 2, 3, 4, 5, 6, 7 zeros here that are not significant. So this number only has 2 significant figures. Now this number, these 3 zeros, not significant. We have 1, 2, 3, 4 significant figures. Okay, so let's look at some examples and just review what we have talked about. So our first example is 75.2. So this has 3 significant figures. They're all non-zero numbers. Our second example, this 4.1 times 10 to the 11th. We have two significant figures, these two right here. And then on our 10.05, these two zeros are captured by two non-zero numbers. So they are significant even if the decimal wasn't there. So that would be 1, 2, 3, 4 significant figures. Coming over here to 7.50 times 10 to the negative 2. So we're just looking at this number right here. And that number has three significant figures. I count this 0 because it meets two requirements, or is what I like to say. It's after a decimal point and it's after a non-zero number. All right, then we have 6 million. So this is a comma there, not a decimal point. So this would have one significant figure. All these zeros are not significant. Coming over to our next example, 31.03, we have 1, 2, 3, and 4 significant figures.